everyone. Notes 3.6 are on finding equations in vertex and factored form. So in the past 2 lessons, you've been given equations and you've been asked to graph them out. Now you're given graphs or descriptions and you're asked to find the equations. So just a reminder that vertex form is y equals a times x minus h squared plus k, x minus h quantity squared plus k, and factored form is y equals a times x minus r times the quantity x minus r, I should say, times the quantity x minus s. And in vertex form, our vertex is hk. And in factored form, r and s tell us the roots or the zeros. Okay? So in the first examples that we have here, it asks us to do it in vertex form. And the reason why vertex form is easier for this kind of a question is the vertex is very clear and very obvious what it is, but also because the roots are not very clear or very obvious what they are. So it would make more sense to use vertex form in the first 2 questions that we have here. So since vertex form is y equals a times x minus h squared plus k, and we know that our vertex is at this point right here, which is 4, -5, then we can say here that h is 4 and k is -5. So I can replace that inside of here. So I can say x minus 4 squared, quantity squared, and then minus 5. But I still don't know the a value, and that's why I left this as an a, because I don't know what it is. So what I need to do now is I have to get another piece of information to find out what a is. Just like we did when we did y equals mx plus b, and we knew what the slope was, but we needed to find out that y-intercept. We would take a point, plug it in, and solve for b. We're going to do the same thing. We're going to take a point, we're going to plug it in, and we're going to solve for a here. And if I look right here, I need to choose a point that I can easily identify what it is. So for example, I know that this point right here is at 2, 3. Or I know that this point right here is at 6, 3. Or I know that this point right here is at 3, -2. Or this point right here is at 5, -2. All of these are all possible values that I can use. It doesn't matter which one I choose. They'll all give me the same a value. So I'm going to choose this one right here, just because it's the first one that I said, but it doesn't matter. So I know that this is the point 2, 3, where 2 represents x and 3 represents y. Now remember, our equation, our final answer has to have x and y in them as just x and y because there's infinite points on my parabola, but I'm going to replace x and y right now so I can solve for a because I just need one variable here. So I'm going to replace the y with 3. I'm going to copy down the a. I'm going to replace the x with 2. I'm going to copy down the -4 squared. And I'm also going to copy down the -5. And now I'm just going to evaluate. So right here, when I solve this right here, 2 minus 4 is -2. I'm going to copy everything else down exactly how I see it. Then I'm going to evaluate what -2 is when I square it. So that gives me 4, +4. Don't forget you have to have brackets around that negative that's being squared. So I get +4a, and then I'm going to copy down the -5, copy down the 3, and now this is just a nice easy equation to solve. Bring the 5 over by adding it, divide both sides by 4, and I get 2 equals a. So now I can go ahead and say that my final equation right here is going to be y equals 2 times x minus 4 squared minus 5. This is the a value, this is the h value, and this is the k value. Okay? Let's go ahead and try this one. So again, roots are not very clear, so we need to use the vertex. So that's why we're going to use vertex form here. And we know the vertex is at 0, 7. This also happens to be the y-intercept, but the fact that it's the vertex is really helpful to us here. So here I'm going to say y equals a times x minus h squared plus k. And I apologize, people, even though, yes, this is x and y, but these are very specific values. This is the h because it's my vertex. This is the k. So I'm going to replace the h and the k with these values. And if you notice here, x minus 0 is just x. So I can just write this out as y equals ax squared plus 7. I don't need brackets. I don't need the 0. Okay. Now I need one other point that I can plug in to solve for a. So if you look right here, I'm just going to use this point right here. Just randomly decided to choose that one because I know exactly what it is. This is the x value. This is the y value. Quick note, I know my parabola is opening down, so my a value better be a negative value. If I don't get a negative number, then I know I did something wrong. I am going to replace the y with a 5, replace the x with a negative 2, and then I'm going to solve for a. So here I end up getting negative 2 squared ends up giving me positive 4. So I get 4a plus 7. Bring the 7 over by subtracting it. Oh, this looks promising. I get a negative value here. Divide both sides by 4. So I get negative 2/4 is a, but I can reduce that to negative 1/2. If you want to say negative 0.5, totally fine with it. But if you get a repeating decimal, you need to leave it as a fraction because we want an exact answer. Okay. So here we can say that our equation is going to be y equals negative 1/2 times x squared plus 7, where we know the a value is negative 1/2, the h value is 0, so we don't have to put anything inside of here, and the k value is 7. Really quick note, we could have also figured out that the a value here was 2 by looking at the step pattern, because right here I go over 1 and up 2. I would go over 1 and up 6 right here. And if you remember, the step pattern is 1a, 3a. So we know that 1a is 2 and 3a is 6. So this means that a has to be 2. This one's a little bit trickier because even though I can see that I go over 1, I'm going down by a certain amount, but I don't know exactly how much it is. But I do know that if I go over 2, I would go down 2. So this is a negative 2. And when I go over 1, this is 1a. And then if I do it again, so up to here is 1a. And we know that down here is 3a. So we know altogether this whole amount right here is 4a. And 4a equals negative 2, which means that a would have to be negative 1/2. But again, you don't have to do it that way. I just wanted to show you how everything is all connected. You can just use the equation, whatever you prefer, as long as you support your reasoning and you communicate your work. All right, people, in our next example, it says write the equation of each quadratic relation in factored form. And the reason why we're going to use factored form this time is because we know the roots. And yes, we do know the vertex in this example here, so we could technically use vertex form for this one. But in this one over here, we don't know, we know the roots, but we don't know exactly what that vertex is going to be. So we would have to use factored form because factored form we use when we know our roots. So let's go ahead and talk about how to do this one. So here I would have y equals a times x minus r times x minus s, okay? And we know that these values are our roots. So here our roots are at -1 and +3. It doesn't matter what order you put it in. I'm just going to say r is -1, s is +3, but you are fully allowed to say the opposite and say that r is 3 and s is -1, as long as you have the correct values there. So right here, I'm going to replace all of that information right here. Now be extra careful because when I replace the r here with a -1, the minus and the negative become a positive. So this becomes x plus 1. And then here, this would become s and then minus, and then the 3 doesn't change the sign, so it stays as a -3. Again, same thing. I know the r, I know the s, but I do not know the a. So I have to pick a point to plug in and solve for a. To do this, I can pick any point that I want as long as it's not a root. And by the way, in this example up here, to solve for a, I can choose any point I want as long as it's not the vertex because I've already used the vertex. And I can't use the root here because I've already used the roots here. So I can use the y-intercept, I can use the vertex, I can use just a random point. It does not matter. So I'm going to use just the y-intercept because the x value is 0, and that makes things nice and easy for me. So I know that this is the point 0, 9, this is x, this is y. I'm going to place that information in here. Notice how this time you're going to plug in the 0 twice because there are two x values here. And then I'm just going to go ahead and evaluate. So here, 0 plus 1 is 1, 0 minus 3 is negative 3, and then I've got a 9 and an a here. So 9 equals 1 times negative 3 is negative 3, and then I've got the a at the end. I prefer to put the variable at the end. It just makes things easier. So here I can say that a is going to equal negative 3, which means that my equation is going to be y equals negative 3 times x plus 1 times x minus 3. Or vice versa, you can also have y equals negative 3 times x minus 3 times x plus 1. Okay? All right, in our last example that we have here, please identify what the r and the s are and come back to see how you did. So you should get r is 0 and s is 7. The next thing I'd like you to try on your own is to replace that into the equation of a parabola in factored form. Try it and then come back to see how you did. So you should have y equals a times x minus 0 times x minus 7, or vice versa. You could have the 7 here and the 0 here. That does not matter. I personally prefer to put the 0 first because x minus 0 is just x. And then this is just a monomial, so it's easier for me to put the monomial first. It's so much easier to deal with it if you have your monomial first. All right, cool. Now all I have to do is just pick a point, plug it in, and solve for a. So here I'll choose this point right here. I know that this point is 1, negative 3. This is my x value. This is my y value. So I'm going to go ahead and plug in that information here. So here I'm going to say negative 3 equals a times 1, because I know the x value is 1, times 1 minus 7. Okay, evaluate this. This becomes negative 6. 1 times negative 6 is negative 6. So I get negative 3 equals negative 6a. Divide both sides by negative 6, and I get a positive 1/2, which means that my equation is 1/2 x times x minus 7. And this is my final answer here. Notice that the a value is positive, my parabola opens up. Notice here that the a value is negative, my parabola opens down. So the algebra is supporting the graph that's going on here. Awesome. All right, in our next example, it says write the equation of each quadratic relation in the form that seems to make the most sense. So in our first example here, we're told that the parabola has a vertex of 4. So if I see vertex of 4, typically I'm going to want to use vertex form. And I can, a vertex of 4 is 0, I should say. And I can plug that information in right here. So I can say y equals a times x minus, remember the h value is 4, the k value is 0. So then I can just say this right here. This plus 0 here, though, isn't really necessary. So I can just say y equals a times x minus 4 squared. But I still don't know what a is. So I have to plug in another piece of information to solve for what a is. Since I'm told that there's an x-intercept of 0, negative 16, we know an x value and a y value that we can plug in. So here, instead of y, I'm going to replace it with negative 16. Instead of x, I'm going to replace it with 0. And then I'm going to copy everything else down exactly how I see it. So here I have negative 16 equals a, or 0 minus 4 is negative 4. So I've got negative 4 squared. Just going to come up here because I'm running out of room. So negative 16 equals, negative 4 squared is positive 16. So I get positive 16a. Divide both sides by 16, a is negative 1. Which means that my equation would have to be y equals negative 1, or just negative x minus 4 quantity squared. And if I were to draw a quick rough sketch of what's going on here, I know that the vertex is at 4, 0, and that it has a y-intercept of negative 16. So I know that my graph will have to look like this, which means that the a value better be negative. Okay? All right, the next example, a parabola with x-intercepts of negative 2, 0 and 6, 0. So if I see that, I say I automatically have to use factored form, because factored form tells us the roots or the x-intercepts. So here we know that the r is negative 2 and that the s is 6, sorry. The r is negative 2, the s is 6, or the other way around, it does not matter. and I'm going to replace that information inside of here. So I'm going to say y equals a times x. The minus and the negative become a positive, and then I've got x minus 6. And then I can just plug in this information right here. I'll do this quickly because we've done several examples of this by now. This is x, this is y. So I'm going to say 6 equals a times 4 plus 2 times 4 minus 6. And then I'm just going to go ahead and evaluate. So 4 plus 2 is 6. 4 minus 6 is negative 2. I've got a 6 here and an a here. 6 times negative 2 is negative 12. So I get negative 12a. Divide both sides by negative 12. I get negative 1/2, which means that my final equation is negative 1/2 times x plus 2 times x minus 6. And this right here is my final answer. Okay, my friends, our last example is a little bit trickier. Let's read through it and then we'll talk about why it's a little bit trickier. So it says a parabola with a stretch factor of 2, so that's going to be helpful. Reflected about the x-axis, that's going to be helpful. Equation of the axis of symmetry is x equals 3, and it goes through the point 2,5. So this time I'm not given the vertex and I'm not given the roots. So I'm a little unsure. Should I use vertex form or should I use factored form? To be honest, both will work, but vertex form will be a little bit easier. So let's go ahead and write out vertex form. So y equals a times x minus h squared plus k. And we know that the vertex would have to occur when x is 3 because it's on the axis of symmetry. So we know our vertex is going to be 3 something. We just don't know what that something is, which means that we know what h is, but we don't know what k is. However, we also know what a is because it tells us that there's a stretch factor of 2 and that comes from the a value. But it's also reflected about the x-axis, which means that it's going to open down, which means a is negative. But it's still information that we know, so this is awesome. So I can go ahead and plug in all the stuff that I know here. So I can replace the a here with negative 2. I can write x minus 3 because I know the h value is 3 squared. But this time, instead of trying to solve for a, I'm going to try to solve for k. So I'm going to use the last piece of information that's given to me, which is that it goes through the point 2,5. So just like we've always done, I'm going to replace the y with the 5, the x with the 2. I'm going to copy everything else down exactly how I see it. And then I'm just going to evaluate and solve for k. So the first thing I'm going to do is my brackets here. So 2 minus 3 is negative 1. I need to square that, and then I'm just going to copy everything else down exactly how I see it. I'll just come up here because I'm running out of room. Negative 1 squared is positive 1. Negative 2 times 1 is negative 2. To solve for k, I just have to get rid of that negative 2 by adding it. So k is 7. So here, this is no longer an unknown. I have every single piece of information I need in order to write this out in vertex form. So here I can say y equals, I know, I wrote the a in here already. I guess I was really excited about this one. So I get y equals negative 2 times x minus 3 because I know the h value is 3 squared, and then plus 7. And this right here is my final answer. And that's it for this video. Please make sure to note down any questions you might have, and I'd be happy to answer those questions for you in class. All right, have a good one. Bye.